Okay, so this is going to do a quick walkthrough here of the study guide. And we went through it in class, um, but I also want to walk through it and kind of, make sure everybody is understands kind of what the topics you want to bone up on for the exam. All right, so you'll find the study guide itself is actually at the bottom of our information systems um, module. Right, last item. All right, so you can download it or you can look at it online. We'll look at it online here. Okay, so uh, from the start, the first thing to look at, going back to the beginning of the term, we talked about data. We introduced the class by talking about data and the mod, basically the triangle: data, information, knowledge, and wisdom. All right, so you want to know, kind of understand the mechanics of that. What each tier means and what happens as we go the uh, up the model. Okay. Um, Also, you want to go back, take a look at, understand what the relative scale of data is. Remember, you talked about structured data versus unstructured data. That 80% of data is actually unstructured, and 20% is structured. So that's a rule of thumb. All right. And also, the thing you also want to do is also make sure you review the relative size of data. So, what the difference between what's greater, a terabyte or a kilobyte? Obviously, the answer is terabyte, but basically and that is in the first presentation we went through. Um, Also, we walk through the different types of information systems and their definitions. You want to be familiar with what they are, the different types, kind of what they do, what their role is, the types of jobs they do. Uh, we talked about some of the different types of databases. All right, so we talked about things like hierarchical databases. We talked about relational databases. So the one thing to remember is relational databases is the most common database currently in use. All right, so if you look at any website that runs a business, at the core of that is likely to be some type of relational database that's driving it. When we take a look at the different types of knowledge and know what we mean by tacit knowledge. So tacit knowledge is the hard one, because tacit knowledge is the combination of knowledge, experience, education, learning, all combined together. All right, so that really is kind of the thing that is really still kind of a human thing. It's difficult for machines to be able to. Machines are very good at a lot of things, but they are not quite that good at tacit knowledge yet. All right. Um, Also, go back and look at the components of an information system. If you remember, what we had talked about was there's really five pieces to an information system, five major components, which are, it's people, process, hardware, software, and data. Right? Those are the five. Technically, you could probably throw network in there as well, maybe network in lieu of process if you were inclined. But I would go with people, process, hardware, software, and data would be the five. All right. Um, you wonder the difference between business analytics and business intelligence. Remember, we talked about the idea of business intelligence is focused on the past, basically taking a collection of information or taking a collection of data and deriving information from that, turning that into information that's looking at what happened. All right. Whereas analytics uh, is looking more forward. All right. So it's actually looking at past behaviors and trying to make some form of analysis or assessment of what future would look like. So that's really the difference between those two. All right. We're going to take a look at what we mean by data mining. So data mining, if you recall, is a form of analytics where we don't know the answer. Right? So what we're looking for, we're going into a set of data and looking for things like patterns and relationships, and and gaining insight around those. Right? So that's really the concept of what we talk about when we talk about data mining. Right? We look at what we talked about with the data warehouse, the idea of a data warehouse, which is a separate system which we populate from data from different sources, different applications, possibly from the internet, that is set up specifically to do reporting, all right, or be able to do, be able to do reporting and analytics against that, all right. And then the idea of a data mart being a smaller version specifically carved out for different functions. So, for example, if you have a regional operation, maybe you want to create a data mart for each region, or if you have a division of an organization that is particularly vociferous in its opinion that it needs its own data, you maybe set up a data mart to handle their data specifically. So the idea is that the data warehouse is a read. We put data into it, and then with the idea of reading it, all right, and then the data warehouses the data marts are subsets of that data. So if we don't take it out of the data warehouse, we simply copy it. All right. So the data warehouse should always have what we would call the single source, ideally the single source of truth. Take a look at the different types of enterprise applications and kind of what they do. So we talked about ERP systems and EIS systems and BI, business intelligence systems and business warehouses. Just you want to be kind of review the major types and classifications, as well as the major functions of an information system. Basically, the core of an information system is 3 steps. You have input, you process it, and you turn it into output. And so if you look at all throughout, up and down the technology stack, from applications down to the until you actually get into the heart of the machine, input, process, output, we see that pattern occurring all the time. Right? Want to review the definition of a business process, which is a set of tasks executed in a particular order with a expectation of a specific output. All right, so you can have many steps in a business process. They can span organizations, they can span operations, but the idea is they are all executed in a particular sequence, in a specified sequence, and that at the end we have a expected outcome. Take a look at what we meant when we talked around the formal definition of a system, and specifically what an information system is. Remember, systems are general in nature. It's an organization. It's an organization that is set up to perform a particular task. Information system is set up to handle a specific set of tasks, leveraging digital information. All right. So we have, like, for example, our central nervous system, which is a system. And then we have an accounts payable system. All right, so those would be kind of the 2 examples. Review what we talked a bit about big data and how is it different than the traditional forms of data. So the idea is that a relational database, the formal definition of it is relational databases, are good when we measure our data in the millions, but when we get up into billions of data elements, it becomes more challenging to use the relational model, and actually other tools and techniques have been adapted to be able to leverage that. All right, so that's kind of what big data is. Data is so big, you can't. It doesn't. No longer a relational database no longer really it helps us. All right. You want to know the difference between a database and a database management system. Remember, a database is the structure. All right, so like a relational database is made up of a bunch of tables, stores data in tables. A hierarchical database stores data in kind of a tree structure. All right, that's the database. The database management system is a piece of software that lets us access, use, manipulate the database. All right, so it sits between us, the end user, and the back end database, and we pass commands to the database management system. It executes it. It talks to the database on our behalf, translates our requests into action, brings the results, and presents the results back to us. All right, so once again, databases are structures. Database management systems is software. Also, when we take a look at, we talk a bit about ERP systems, the characteristics of it, the key characteristics, in a word or in a sentence, it's the integrated management of end-to-end processes for an organization. Key words to look at when we're talking about ERP systems is this integration. We'll see this in action, how these things are all tied together, but the integration is a key concept. And also the idea of these end-to-end business processes. We'll see kind of how organizations actually do work, within these end-to-end business processes. You want to take a look at, this idea of, the role of an information system. It's focused of taking data and transforming it into information. And then how we look at things like knowledge management and business intelligence builds upon this to be able to take information and help us, drive it into knowledge. All right, so there's like layers of transformations. There's a data to information transformation, and then a information into knowledge transformation. So information systems handle the first one, and knowledge management and business intelligence applications help us do the second one. You want to take a look at Moore's, just kind of take a look at Moore's law. What do we mean by Moore's law? Why is it important? So obviously, the importance of Moore's law was the observation that computers get faster and faster and cheaper over time. The idea of doubling capacity on a 12 to 24 month basis, which has really been in effect since the mid 60s, and has really been the foundation. We've come to expect that computers will continue to get faster and become have more faster, gives us more capability, while maintaining really maintaining the cost. So that's once again, it's not an official rule. It's not quite like the theory of relativity, but it's an observation that's basically is held true, for a long period of time. We talked a little bit about different approaches to artificial intelligence. So just kind of be familiar with the terms of fuzzy logic and neural networks. Those are types of artificial intelligence approaches. Intelligent agents. So we talked about those different. You can find those in the presentations. We had talked about kind of what they are, kind of what they do. You want to take a look at the difference between a data warehouse and a database. When we say a database, we talk about like an operational database that we use maybe for transaction processing systems. We have a slide. There's a slide in the deck talking about that. You can kind of look at that for the comparison. And in addition, also look at the difference between business intelligence and predictive analytics. So once again, business intelligence, looking backwards, focused on reporting. Whereas predictive analytics is looking, kind of taking, what we have accumulated, kind of the historical information, using it as a starting point, and then looking forward to try to gain insights into what possible outcomes a decision maker should consider or should weigh, in evaluating situations. And finally, the last part is, and kind of going back to our big data question, the big three components of big data, all right, which are what we call the three V's. and these are the things that really have driven big data. So it's the volume of data, which is really talking about size, which is driven by numbers of devices generating digital data. We have the velocity of data, which is the speed by which it shows up, which is now seemingly instantaneous. And then the variety of data from different sources. So the idea is the combination of these three things are the thing that drives this growth of data. So we get more and more larger and larger volumes, faster delivery of data, velocity of data, and then the variety, different sources of data. All right. So the exam itself will be still noodling on it a little bit. About 30. It looks to be about 30 questions. There might be one additional, one or two. I have to see kind of how it plays out. Probably most of them are going to be multiple choice, and some fill in the multiple choice, true, false. A couple fill in the blanks. All right, so something around things like the the components of an information system. Those 5 components might be a category of a fill in the blank question, but not. I'll probably only have 1 or 2 of those. Alrighty, and if there's any questions between now and Wednesday, Friday, give me a yell. You just send me an email, and I'll get back to you as quickly as I can. Right. Thanks a lot, and I'll talk to you soon. Take care.